Okay, so today we're going to talk about plate tectonics. First off, remember, pause and read whenever you need to, look out for test question alerts, and write down all highlighted vocabulary terms. So the theory of plate tectonics basically revolves around the Earth has plates, which are basically pieces of the Earth's crust. It's kind of like an eggshell. So when you drop an eggshell and it cracks, it doesn't crack evenly. So just like that, the crust of the Earth is not even. And plates meet at boundaries, and you can see your boundaries here. So here's our plate. This is the North America plate. It goes all from here all the way down over here. Longitudinal plates here. You got your Nazca plate, and they move by the convection of the mantle. So how they move is convection currents in the mantle push the plates. As the currents flow, and remember we talked about that. That's where the magma cools and warms up, and it forms a circle just like a bowl of soup. And plates move above them until they reach a plate boundary. There are three basic types of plate boundaries, and we're going to go in more detail in just a second. But we have a divergent boundary in which the plates move apart. You have a convergent boundary where the plates come together, and you have a transform boundary where the plates slide past each other. So as the plates move, they collide, move away, and slip past each other. We just talked about that. This creates faults, which are breaks in the Earth's crust where rocks have slipped past each other. So our first type of boundary is a convergent boundary, and that's where two plates move toward each other and collide. So the Andes Mountains are a classic example of this. The density of the plates determine what happens. So remember, continental crust is less dense than oceanic crust. So whichever plate is less dense gets pushed up, and the more dense crust gets forced down. So if oceanic crust collides with a continental crust, the continental crust gets pushed down and you get an ocean ridge. If oceanic hits oceanic, they basically will just sit there and you get a rift valley. If continental meets continental, and this is the one that I want you to make sure you remember, they push up and they form mountain ranges. So here we have two plates that collided that formed a mountain range. Divergent boundaries are where two plates move away from each other. And in Iceland, there's actually one that you can walk in. So that's right here. This is one side of the plate, this is the other side of the plate, and this is what's in between them. These two plates are moving apart. So one plate is moving this way, while the other plate is moving this way. And it's creating this valley in here. And that's called a rift valley. And that's a deep valley formed when plates diverge on land. And most divergent boundaries form along mid-ocean ridges. Then we have a transform boundary. And a transform boundary is where two plates slip past each other, and the classic example of this is the San Andreas Fault. Earthquakes will typically happen along these boundaries. So what happens is they lock together, so we have our plate here, and that's moving this way, and we have our plate here, and that's moving this way. So they lock together, and eventually the force is great enough to move one of the plates. So again, up here we have they're moving this way, and that's when we get our earthquake. So tomorrow, be ready for your screencast quiz, and be ready to model boundaries in the lab next class. We're going to use food. Be ready for that. I have already warned you about what we're doing in class today, so be ready for that, and that's all I have for you.